Today, we're going to pull back the curtain on a concept that, honestly, keeps our digital world from falling apart, especially when your money's on the line. We're talking about idempotency. Yeah, it's a mouthful, but it stands for a really simple, incredibly powerful idea that stops digital disasters before they happen. You know the feeling. We have all been there. You're buying something online, you hit that pay button, and crickets. The little spinner just keeps spinning, or you get some dreaded timeout error. And your first thought is pure panic. Did it work? Am I about to get charged twice if I hit this button again? So what do? You do what we all do. You mash that refresh button, try again, and just cross your fingers. But that little seed of doubt is planted. What if that first click did work before the connection dropped? You might have just paid twice. And in the world of distributed systems, that is a massive problem. And look, this isn't just some tiny glitch. It's a critical, fundamental issue. We're calling it the double charge problem here, but it applies to any action that should only happen once. Think about creating a new user account, placing an order, or changing inventory levels. If you don't have the right safeguards, retrying an operation can create chaos, data corruption, and, let's be honest, really angry customers. The solution? It all comes down to a property called idempotency.
So what in the world is idempotency? To put it simply, an operation is idempotent if you can just hammer away at it, do it 1 time, 5 times, 100 times, and the end result is exactly the same as if you'd just done it once. It's basically a guarantee of safety and predictability in the wild, unpredictable world of the internet.
Probably the best way to wrap your head around this is to look at something developers see every single day: HTTP methods. It turns out some of these are built to be idempotent from the get-go, while others, well, not so much.
Just think about it for a second. A GET request, right? You're just asking for a user's profile. You can do that a million times. You're just going to get the same profile back. It's idempotent. Same with a PUT request to update an address to the same address. It's safe. And delete, well, the first time you call it, the thing gets deleted. Every time after that, nothing happens. It's already gone. But then there's POST. A POST request is usually for creating something totally new, like a payment. It is not idempotent. Every single time you send that request, you're running the risk of creating a brand new thing. So this leads us to the big question, doesn't it? If these super important actions, like payments, use these non-idempotent methods like POST, how on earth do we stop them from making dangerous duplicates when things go wrong? How do we give them the superpower of idempotency? The answer is actually a really clever trick called an idempotency key. You can think of it like a one-of-a-kind digital receipt or a tracking number for every single operation. And what's really important here is that the client, so your web browser or your phone app, it generates this key before it even thinks about sending the first request. Okay, so we have this key, but how does the server on the other end actually use it to stop those duplicates in their tracks? Let's follow a single request on its journey and see exactly how this works. All right, step 1, your app creates a totally unique key. Step 2, it bundles that key up with your payment info and sends it off, usually in a special header. Now, when the server gets it, its very first job is to ask one simple question: have I seen this key before? If the answer is no, it processes the payment like normal, and then, and this is the absolute key to the whole thing, it saves the result of that payment and it ties it to that unique key. So now, if that same request shows up again because of a retry, the server sees that key, recognizes it, and says, whoa, I've already done this, and it stops right there. That's right. The server doesn't even try to process the payment a second time. It just goes into its records, finds the original response it saved, whether that was a success or a card declined, and it sends that exact same response back. From your app's point of view, it just looks like a normal response. But behind the scenes, no money was moved twice. Problem solved.
Now, putting this into practice sounds pretty straightforward, right? But, the devil's in the details, and there are a few common traps that can catch developers. So let's run through some best practices to make sure your system is absolutely rock solid.
Here are the big ones. First off, your keys have got to be strong and unpredictable. Use something like a UUID v4. It's basically a super long, random number that's guaranteed to be unique. Second, only cache the final result of a request. Never save a temporary network hiccup error. Third, you have to plan for race conditions. That's when 2 identical requests hit your server at the exact same millisecond. You need something like a database lock to make sure only one of them gets through. And finally, don't be a data hoarder. These keys don't need to live forever. Set an expiration time, say 24 hours, to keep your database clean. Oh, and here is a massive point for security. The server can't just check if the key is the same, it also has to check that the rest of the request is identical. Think about it. If someone tries to send the same key but with a different payment amount, you want the server to reject that immediately. This stops a key from one transaction from being accidentally or maliciously reused for a completely different one. So, we started this whole conversation with a simple online payment, but the importance of idempotency goes so much further than that. It's really one of the foundational building blocks of reliable, modern software. And once you start looking for it, you see this principle absolutely everywhere. It's vital for e-commerce order systems, for managing warehouse inventory, for the message queues that power huge backends, and for all the tiny little messages flying between microservices. In every single one of these cases, idempotency is the silent hero, making sure that things can be safely retried without wrecking all the data. When you boil it all down, all these complex techniques, the keys, the locks, the validation checks, they all serve one single powerful goal. And that goal is to guarantee data consistency and integrity. In a world of incredibly complex systems spread all over the globe, where networks fail all the time, idempotency isn't just a nice-to-have feature. It is an absolute must-have for building software that people can actually trust. The big takeaway here is that idempotency makes it safe to try again. It takes a chaotic, unpredictable failure and turns it into a predictable, safe outcome. So now that you're in on the secret of how reliable systems handle this stuff, it kind of makes you wonder, right? Where else in our digital lives could this simple idea be used to make things just a little bit more reliable for all of us?